Welcome to the center of the universe at the Dominion Astrophysical Observatory. We are extremely happy that we can work and explore, and in my case, I get to play, up here in the territory that belongs to the Wasanic people that live on these lands up on the Saanich Peninsula, and who also were the first peoples in all of the Gulf Islands around in here. And we acknowledge that they are the traditional people on these lands, and they call this hill Watixis. And that is it is a very special place for them, and we're very proud that we have been able to make some really good connections, and we are starting to do some real work with some of the Wasanic people from the territory around here, to be able to increase our programming and to do some of the work that we need to do. My name is Laurie Roche. I'm one of the directors of the Friends of the DAO. We have Ben Dorman, who's our chairperson here, who just gave a little bit of a presentation in the planetarium. And thank you for keeping on time, Ben. There we go. So tonight, you'll probably notice, right first thing, that in all the advertising, I said that there were 3 fabulously wonderful historians. How many are at the table? 2.
Some people would say 1.5.
Yeah, 1.5.
So does that make us even more fabulous then?
Even more fabulous, absolutely. Apologies, Randy Attwood, who is in Victoria, found out at about noon today that he has COVID. And we said, no, Randy, we don't want you to come. So unfortunately, he was on a ship. He was on an Alaskan cruise, and when he came back, he's been back for about 3 days, and he now has COVID. So he phoned and apologized very much. But he really was looking forward to this. We don't have Randy in Victoria very often. And when I found out that Randy was coming, I cajoled these 2 lovely gentlemen over here to be with Randy. And then so he has sent his apologies for not being here. And I thought for about 2 seconds, well, I wonder if you could do your presentation from home and we could do it. And then I said, no, that was not a nice thing for me to even think about. So he is recovering, and we'll get him the next time he comes to Victoria. We'll make sure that we have him here. But we do have 2 fabulously amazing people that are going to take up the space of 3. And so this is Bob McDonald. Is there, and Chris Gainor. So Chris is a historian for technology, and writes specifically on space exploration and aeronautics. He's the author of 6 books. How many do you have, Bob?
7.
Oh.
Like the 2 and 3.
Sorry, Bob.
Get to work.
That's right. Yeah.
But he's had a lifetime of journalism and of writing. He has a PhD in history of technology from the University of Alberta, and his most recent book is a treatise on the Hubble Space Telescope that NASA has asked him to write, and it is an amazing volume of everything that is about Hubble, and is now a major thing to have in libraries and to keep for any past history of that. We're very happy to have Chris as our reigning president of the Royal Astronomical Society here in Victoria. We have 30 centres across Canada, Victoria being the second oldest, is that correct? We're the second oldest RASC center. Is that correct? Toronto first and then us?
I'm not sure about that.
We may even be first.
No.
Okay. Oh.
Just has the oldest
Close,
members.
but close. We're up there, but we might not. Okay, all right. But Chris is our president at the moment, and he also has been president of the National Royal Astronomical Society, so he's done all of those kind of administrative tasks. He's presently on the journalism team at the National RASC and helping to produce some new books that are coming out from the RASC. So Bob, how many of you know Bob?
Few.
Yeah, okay, all right. Needs very little introduction, but I'm going to do it anyway. He is the presenter of Quirks and Quarks, of course, at CBC, and also is on the National, and also is on CBC Radio at about 7:20 on Friday mornings, right?
Saturday morning, yeah.
Saturday mornings,
yeah.
and Saturdays, yeah. But with the CPC one that we have here, that you're on about 7:20 on Friday.
CBC.
On
Yes,
Fridays,
yes,
yeah,
local, yes.
He writes a blog. You can kind of keep up with him kind of all the time. He's got a couple of his books here, so he's going to talk to you a little bit about some of his books. And Bob has been in the industry for a number of years. And he's done all kinds of, he's worked in a lot of places. He's done an awful lot of public outreach. His journalism is just, is amazing. And he has won so many awards that it takes about 2 inches on the page for all the awards that he's won. It kind of goes down. And even one from the McNeil Medal from the Royal Society of Canada. Both of these, yes.
He's been a member of the Friends of the Creative Board right from the beginning.
How could I forget? I'm sorry, Bob.
That's okay.
Yes, he was right in at the very, very beginning of when this place closed down in 2013. Bob came to our came and said, I want to be involved, and has been on the board of directors since 2013, since we became a society in 2015. So we do appreciate his expertise, his humor. He tells really bad jokes sometimes. Oh my goodness, we have to really watch him sometimes, but that's okay. I want to also say that all three, if Randy was here, I was actually going to try to introduce them by putting up 3 asteroids up on here, because all 3 of these have their own asteroids that are here. So it's absolutely amazing. I'm going to invite Bob to come and speak first. And because we've had to do a little bit of some switching of the program, and I've asked both of these gentlemen to kind of add a little bit of some extra things to their presentations. I'm sure that you will be entranced by some of the stories from Canada in space. And I'd like to introduce, first of all, Bob McDonald.
Thanks, Lynn. Just right off the bat, my asteroid will not hit the Earth, okay? Will not hit the Earth. David Balin, the astronomer from here who found it and who named it after me, he said, my asteroid, it's out between Mars and Jupiter, and it's about the size of this mountain that we're on right now. So that's about how big my asteroid is. All I need to get is to get to it. And I'll sell you some real estate if you like. Before I begin, I want to tell you a funny story. We're talking about Canada in space tonight. And a few years ago, I was invited to give a talk in the United States in Chicago at a space conference. And I got up to the podium and I said, hi, I'm from the little country just north of here called Canada. I said, and you may not realize this, but we were the 3rd country in space. The room goes quiet. I said, yeah, you know, the Russians were first with Sputnik in 1957, and you were second with Alouette, or with Explorer 1 in 1958, and we were 3rd with Alouette 1 in 1962. And they all go, yeah, oh, and they're all checking their phones. And then I said, and you know something, that both Sputnik and Explorer 1 have since fallen out of their orbits and burned up in the atmosphere. Alouette's still up there. And they're all going, that can't be right, that can't be right. No, but it's true. This satellite right here is still up there. They put it into a really high orbit, so it hasn't come down. And I met some of the people who actually built it. And they said, if we had the codes, we could probably turn it back on again, because it didn't die. They actually turned it off because it had worked for so long. So we have a long, long history in space, long history. And Chris is going to tell you more about our early history, but I want to talk to you about some of the special people, some of the special astronauts that we've had that I outlined in my book, Canadian Spacewalkers, which they don't have here anymore. Apparently it's on order. This book came out quite a while ago, but it's my first full-color book, and one of the most beautiful that I put out. I'm quite proud of this one. And it outlines 3 of our spacewalkers. At the time I wrote the book, there were only 3 Canadians who had flown in space. Now, the first was Chris Hadfield on his second flight into space. His first one was up to the Russian space station Mir in 1995. I went to Russia when he was training there, and I met him, and we took a walk in Red Square in Moscow. And I said, I can't believe I'm walking through Red Square with a Canadian astronaut who's going to go up on an American space shuttle to a Russian space station. And he said, yeah, especially since I had Russian bombers in the gun sights of my F-18 when I was a fighter pilot. But that was a time when the Soviet Union had collapsed, and the Russian space program was looking for customers, and they made a deal with the US to use the Mir as a practice on how to dock a shuttle to a space station. Chris did not take a spacewalk on that, but he did on his second flight when Canadarm 2 went up to the International Space Station, and he was the guy who actually mounted it on the side of the space station. And he was the first Canadian to step outside. Spacewalking is the next level in astronaut training. You know, it's enough to become an astronaut. It takes so much just to do that. But then to go outside, it takes another level of training to be able to put on a spacesuit and actually step out into the void. And all 3 of them talked about how profound that experience was. One of them said, it's like the difference between driving through Banff National Park in a bus, looking out the window, taking pictures, or driving in a convertible with the top down, where you can see everything. You can look around in all directions. So Chris was the first, and there's a funny thing here. You'll notice the flag on his shoulder is a little curled on the edge. That's because when he went up, there was an American flag on the shoulder, because they didn't realize that Canadians are different from Americans, but he brought that flag with him. And before he went out, he took some double-sided medical tape, and he just slapped it on. He said, I'm a Canadian, don't forget it. So that was a flag that he put on himself. Hi, Ben, everything okay?
Just getting rid of the thing that's
Oh, thank you.
pressing the high button.
Okay. Now, one thing that did happen when he went out, and he wrote about it in his book, An Astronaut's Guide to Earth, was that while he was up there, they polished the inside of their visors to keep them nice and clear so that they can see, and they used some kind of soap that's called, I think, No More Tears or something like that. And they polish it and polish it and polish it. When he got out into space, they have a little bottle of water, a little bag of water in their helmet so they can drink, because they're out like 7-8 hours at a time. And they get quite hot in there, and they're working hard because the suit inflates, they have to fight it, and they lose weight in space from sweat. So there's a little nozzle that they can just take a sip out of this thing while they're out there. Well, they bite it to open the valve, and then when they let go, it's supposed to close. Well, the valve didn't quite close, so a little drop came out and went across and went into his eye. And it picked up some of the soap vapor that was in his helmet, and his eyes completely closed. And then the drop in zero gravity wandered across his eye, over the bridge of his nose, and into his other one. So at first he's gone, okay, I can see, I'm okay. They're going, yeah. Then he lost sight. He was blind in space. And he didn't want to get back in. This is my first time on a spacewalk. I don't want to kill it. So he just started blinking and blinking and blinking and blinking and blinking, and finally he got it. And he got his vision back again. So that was his first experience in space, going blind. But he managed to get over that. So he was the first Canadian. Then we had Steve McLean, who is an interesting guy. He's an engineer. He's now working on quantum computers, and he was also the head of the Canadian Space Agency for a while. And he went out. I don't know if can you see him in this picture? He's see, does this work? Right there. Gives you an idea of the scale of how large the space station is. It's I had the fortune of doing a virtual spacewalk in Houston where they trained the astronauts, and I did it with our next Canadian astronaut, Jeremy Hansen, who's going to be going to the moon probably next year. And back then, they had these very big helmets things that you put on, and we sat in swivel chairs back to back with a helmet on that had projectors in it, a chest plate that monitors the position of your body, and gloves that were wired. And the room itself was wired for position, so you could move your hands around and the room would record it. And so we're sitting there back to back. They said, okay, we're going to turn it on. The first thing I see are just two hands in blackness. And they're going, oh, hands. It's like a baby, you know, oh, hands, like this. And then they said, all right, we're going to put you on the end of the Canadarm. Great, so blink, and they just click, right? So I'm perched on the end of the Canadarm, and I look down, and I could see the whole space station laid out. All of it. And I knew the modules. There's the European module, there's the American module, there's the Russian one with the wings of the solar panels sticking out, gold. You know, the thing's bigger than a football field, including the end zones. So here I am perched on the end, looking down on this. It was really great. But then behind it was black. Well, where's the Earth? Sure, they have the Earth in this model, this sophisticated model, high resolution. And then I thought, space is three-dimensional. So I leaned back in my chair like this, and looked like back like that, space station disappears. The Earth was over my head because I was actually under the space station with the space station up, and my head was down. And I looked up like this, and I see this beautiful blue curve. And all I could see was water, and I had no idea where I was. And then this brown line went by. It was a beach on an island somewhere, maybe in the Pacific, and it just kind of went by. But that was, and then they said, okay, we're going to put you on the structure now. So in an edit, all of a sudden, I'm up against steel and metal. And it was like, you know, okay, here we are, like this. And they have yellow grab rails. And they said, just, you can grab a grab rail and pull yourself along, like this. Okay, so I started moving around, but I had no idea where I was on this gigantic structure. And they said, here comes night. And it gets dark really fast because it's going around the Earth. And all of a sudden, all I could see was the circle of light in front of my head from the headlights on the spacesuit, but totally disoriented, totally disoriented. And I said to Jeremy, I said, I don't see you, where are you? He said, I think I'm over your head again. So I looked up and I see the top of his helmet because we were head to head this way. I said, hey, reach up, we can shake hands. So I look up and I see him reaching up like this, and I reached up and two Canadians shook hands in virtual space. It was wonderful. It was wonderful. So that's the closest to doing a spacewalk myself that I ever got, was doing it virtually, but it was a very, very powerful experience. So that's Steve McLean. Our third spacewalker is David Williams, a medical doctor, and he did hold the record. I think he still holds the record for the longest time out during a spacewalk, and he did repairs. Here he is carrying one of the gyroscopes for the space station that needed to be moved. And you can move really large objects in space because they're weightless, but you have to be careful because they don't have weight, but they still have mass. So you got to be careful when you move something, you got to stop it again. But the Canadarm does that. They just kind of hang on, and he's on the end of Canadarm, and they move them around like on a cherry picker. So that's Dave Williams. So those were the three that had flown in space when I wrote the book. Since then, David Saint-Jacques has also been up in space. He holds the record for the longest time in space by a Canadian. He lived on the space station for 209 days. And he's a medical doctor as well. And in fact, during COVID, he retired from the space agency for a while to go back and do medical work because he felt that was more important. But he also went outside doing maintenance on the space station while he was there. So those are the four Canadians who've gone out. And then I'm sure you were watching last week when Jared Cushman, the guy in the middle here, did a private spacewalk, a billionaire who bought his way into space. He paid for the whole mission and went out into space, and they were all, oh, he did a spacewalk, he did a spacewalk. And he didn't do a spacewalk. He stuck his head out the door, and he waved his arms around a little bit, and he said, okay, I can move the suit. And then he went back in. He said, great view, yeah, but he didn't leave. I laughed at this. So like, everybody made a big, big deal about it. But I think it's hilarious because almost 60 years ago, it'll be 60 years next year, Russian cosmonaut Alexei Leonov made the first spacewalk. 60 years ago, and he went outside. And I have a short video here. Let me see if this works. Okay, I'm not sure if I can do this, but just bear with me for 1 second. I got it on YouTube. I actually have his spacewalk on YouTube here. Let's see if I can make this work. There it is. Okay, you got it? See it up? Ah, here we are. Okay, let's see what happens. So here he is. He floats himself away. He was on a tether, and he floated away, and he went, wow, I can see everything. This is really great. He was having a good time. But the suit that he was wearing was not a tight-fitting suit. They actually have it on display. I saw it last time I was in Moscow, which was before Ukraine. And it's fairly loose-fitting. And when he got himself out there floating away, it inflated. And he found it hard to move his arms. They still find it kind of hard today to move around in a spacesuit because there's a vacuum outside. So the air inside blows it up. So astronauts have to do a lot of upper body work to stay strong so they can just move their arms around. But after he was out for just a few minutes, he found that his feet were coming out of the boots because the suit was getting bigger. And so he thought, okay, time to come back in. Pulled on the cord, and they had an inflatable airlock on his Soyuz capsule that he had to get back into. And when he went to get back in, he didn't fit. His suit was too big. He couldn't get through the hatch. And he's struggling. He's trying to get in, and he couldn't make it. And his temperature started going up, and his heart rate was going up, and the doctors on the ground were getting worried. But he had to get in. You can't spend your time coming back to Earth on the outside of a spaceship. You got to be in with the door closed. So the only way he could get in was to let air out of his suit, to deflate it a little bit. And he risked hypoxia, which is loss of oxygen to the brain. But he did that to deflate the suit, got himself back in, and the Russians didn't do spacewalks for a long time afterwards because of that. The following year, the Americans did it with Ed White. Here he is in one of the Gemini flights. He didn't have any trouble because he had a much bigger door. And he floated around for a while. Unfortunately, he was killed in Apollo 1, the fire of Apollo 1 in this, but he was the first to do a spacewalk. So it's been around for a long time. So this billionaire sticking his head out the door last week is laughable to me. It's funny that so many years later, we're still trying to fly in space like they did so many years ago, and we're still trying to get back to the moon. When I was a kid, and when some of you were kids, we thought by this time, by the 21st century, we would be on Mars by now. I thought that's what I thought anyway. Gee, holy cow! Speaking of old, oops, which I am. There were two old guys in a hospital. Oh, I'm on the wrong side? Oh, there we are. Two old guys in a hospital. One of them was on his deathbed. And the other guy said, Harry, we've known each other all our lives, and we've played baseball all our lives. So I have a favor to ask you. When you get on the other side, can you contact me and let me know if there's baseball in heaven? Harry said, well, I'll see what I can do. So he passes on. A few nights later, George gets a voice in the night, and he says, Harry, is that you? He goes, yes, it's me. Are you in heaven? Yes, I'm in heaven. Is there baseball in heaven? Well, I got some good news and some not so good news. What's the good news? There's baseball in heaven. The field is perfect. It never rains, and we can play with all the greats from the past. That's wonderful. What's the not so good news? Well, you're pitching next Tuesday. Where was I? Okay, sorry. Okay, So Chris Hadfield, Steve McLean, Dave Williams, and David Saint-Jacques, and this guy, and Alexei Leonov, and Ed White. So in order to do spacewalking, they have to train underwater, and they wear actual suits that would be used in space. And the first thing they have to do is put on this white underwear garment, which is threaded with plastic tubes, and they run water through those tubes. They completely surround the body, and that's the air conditioning, to both keep them warm or cool them down. Because in space, when you're in the sunlight, it can be 250 degrees above zero, and when they go around to the night side of the Earth, it can be 250 below. So they need to spread the heat around their body. That's why spacesuits are white, to reflect the sunlight during the daytime. So that's the first thing they do. The current spacesuits that they have on the space station, they start on the floor, they put the pants on first, and then after that, they have a harness that they hold on to the upper part of the body, which is hard. It's a hard shell. So then they have to crawl up underneath that, almost dislocate their shoulders till their head pops through the top, and then they attach the pants to the upper part, attach the arms and the helmet, and they're built. So that's how they do it here on Earth. And he's got weights on his chest so that when they put him in the water, and they need a crane to do that, and they go down in pairs, there's one on each side, they're back to back there. So they drop them down into the water, and then once they're in the water, they become weightless, neutrally buoyant, which is the closest we can get to weightlessness on Earth. And underwater, they have a full-scale model of the space station, or whatever satellite they're going to be working on, or whatever thing they're going to be doing. And they go through all the motions that they're going to do in space underwater. And they practice it again and again and again. So when they get into space, they won't get lost like I did. They'll know which way to go. I come out the hatch, I grab the railing to the right, and I go this way, or whatever, so that they always know where they are by doing it underwater first. In order to get out, once they're up in space, the airlock that they have to go through to get outside is so small they have to face in opposite directions. So one of them comes out head first, the other one comes out feet first. And I asked them, I said, when you come out that hatch, it's on the bottom of the space station looking down at the Earth. They're 400 kilometers up. I said, do you get a sense of falling, like height? And all three of them said no, but some people do, especially if you come out feet first. Come out this way, ah! Then you don't fall. It's like, what's wrong with this picture? But it is a very disoriented thing to have up and down all confused depending on where you are. And then, of course, once they're out there, whatever they have to do, they get to it, and it's very tedious. Just a couple of nice pictures here of our Canadians outside. They have their tools on their belt, and they're also tethered. They have a tether. Oh, I know what I wanted to show you. Let me go back. Yeah, this one here. You'll notice on the back of the suit, there's this device here, which is separate from the suit. And these little holes here are actual thrusters. And that's an emergency return device. They back into it after they put their suit on. They back into that, and it has a little hand controller that can come down. So if they get detached from the station and they start to drift away, they turn this thing on, and if they're tumbling, it can stop them from tumbling around, and then they can orient themselves to the space station and fly themselves back. It's got just enough fuel to do that. They can't do like in the movie Gravity, where George Clooney's, flying around like a maniac. They can't do that, but they can. It's an emergency pack. So far, no one's ever had to use it, but they wear that as a safety. So they have a tether and their tools, and they go here, undo the tether. They're always attached. Although Chris Hadfield did tell me that while he was outside, when he had a break in the action, he was holding on at the outside of the station with one arm, and he extended it as far as he could, and he faced in the forward direction that they were moving. And he said, boy, hanging on to the outside of a spaceship at 30,000 kilometers an hour is quite a ride. He said, it's quite a ride. And then just for a moment, he let go. But he was tethered and all that. And all that. Let me just keep going. Are we doing okay for time? Yeah, they do they use the Canadarm, as I say, like a cherry picker to move around to the different parts of it. And then there's the nighttime view. that we don't always see during the thing. This is Quebec. That circle there, that's the Manicouagan crater, which is an impact. Yeah, this circle here. Yeah, that's in Quebec. St. Lawrence River's down here. Oh.
There's a picture right above the meteorite in the gallery.
In the gallery? Yeah, that'll explain that. Yeah, it's one of the more recent impacts on the Earth. It's in central Quebec. 214 million years, there you go. Chris Hadfield said that the northern lights, as seen from space, you're looking down on them, and he said it's like somebody took a knife and just ripped into the Earth, and these green lasers are shining up through the cracks. He said it's unbelievable, the view that they get from space. And they get both northern and southern lights. They see them in the southern hemisphere as well. So the nighttime view is really quite remarkable. And here's a view that Steve McLean talked about. While he was flying over Montreal, he wanted to look down and see his home city, which is just off the frame here. It's down over here. This is Quebec City. And he said all he did was just turn his head to the right, and he could see all the way down the St. Lawrence. There's the Gaspé Peninsula. There's PEI, Nova Scotia, New Brunswick, and a little bit of Newfoundland way over there. All in one view, just by turning his head. That's the kind of view that they get when they're up in space. It's the overview effect, they call it, of everybody who's been to space. In the future, they're going to redesign spacesuits. This is one model. They've got a number of them that they want to design for going back to the moon. The suits now never touch ground, so they can be fairly bulky because they're just floating around in space. But on the moon, you want something that's a little more flexible and easier to move around in, because you're going to be picking up rocks or whatever they're going to be doing there. And what's interesting about this one is that it has, you get into it from the back. And the idea is that you attach it to the rover and the suit always stays outside. So the suit gets dirty, suits get dirty when they're on the moon. And one of the problems they had during the Apollo missions was when they came back, the suits were all covered in dust, and that dust was getting into the equipment and into their lungs and everything. And lunar dust is really sharp. It's very shardy because there's no water to smooth it out. And so this idea is that the suit stays on the outside, you open a hatch on the inside, you crawl into your suit, close the hatch, and then just step away and do your walk. And when you come back, you just back into it. It's one idea for spacesuits in the future. And here's one. I'm not sure they'll do this, but it's a skin-tight suit. And the idea is instead of using air pressure to keep pressure on your body, because we need air pressure to keep our fluids from boiling, right? You don't want your blood to boil, so we need air pressure around us. This suit does it with elasticity. So the suit squeezes your body and provides the pressure that way. To again make things more flexible. This has never been tried in space or in a vacuum chamber, but it's a concept. So we're looking for ways that we can adapt to ourselves to these unusual environments. And yeah, so the book is called Spacewalkers. I also had another book that I wrote after that called An Earthling's Guide to Outer Space, which they don't have here yet, but you can get it on Amazon. And this is an activity book for young people. And so it's got lots of things that you can do at home in it, all space-based. And then my other book, which just came out this week, but has already made the BC bestseller list, is called Just Say Yes, and this is a memoir. People keep asking me, what's your background? How did you get to be where you are? So I wrote it down. So this is my story right from the very beginning, from growing up in small-town Ontario in a low-income alcoholic family, dropping out of university, and being a construction worker, actually, before I started my career. So if you want to know how I got from that to here, it's all in there. And I'll be at the Sydney Lit Fest. When is it? A week tomorrow, I think, the 27th. And I'll be there as well. So thank you. We should be proud of our Canadian contribution to the space program. We've been there since the very beginning, and we'll be there in the future. There's a new space station they're planning to build around the moon called Gateway. There will be a Canadarm 3 on that. So we'll be there with robotics. And again, Jeremy Hansen is going to be on the next flight to the moon, a Canadian going to the moon. How neat. And we'll have Canadian astronauts and robotics on the moon as well. So lots to look forward to. So I'll leave it there. And Chris, you can take us back even further in time. Thank you.
Chris, just before you start, there is someone has a Camry, license plate 225 ASO, color gray. Okay, that's yours. Is that yours? Your light is on in the car, so inside the car, your light is on. So. Okay, I just wanted to let you know. Okay.
Okay, I should see. I gotta change the. Oh.
Okay, want to take that out? Shall I just leave it?
I just need to change the presentation, right?
Yeah. Hold on.
Okay. Yes. So one of the things I do is that I. Yes, I know. We'll get that changed in a second.
Okay. Okay.
Is that I run a little historical journal in spaceflight, and I see a lot of books on space, and I really like this one. It's a beautiful book. It's full of interesting stuff, and it's on a topic that isn't written about very much. So I really recommend this book, and if you're interested in getting a real nitty-gritty view of astronaut life. And so we'll just wait a minute and. So I used to be in the media, and in fact, for a brief period of time, I even worked as a construction worker, but I wasn't very good at that, and I moved on from journalism to history, and we often ask historians, well, why and how did things happen? So in the past few months, I've been working on the history of the Canadarm, and which is a really vital part of the Canadian space program. And I'm going to start off a little bit where Bob left off, mentioning the Canadarm3, which is supposed to be delivered to the U.S., I think, in 2028, and I'm not sure when the thing is going to be launched on Gateway, but this is part of the Artemis program. And part of the agreement that Canada has with the United States and the other partners in Artemis involves getting Canadian astronauts going to the moon. And so the fact that we're building Canadarm3 and contributing that to the Lunar Gateway Station, which eventually will be orbiting the moon, in return for that, or one of the things we get in return for that, is that Jeremy Hansen will be going to the moon, hopefully next year. It might be a little later than that. And this actually has a bit of a precedent in the history of spaceflight. Now, one of the reasons for having this talk tonight, aside from Randy supposed to be here, was that in a couple of weeks it's going to be the 40th anniversary of the first flight of a Canadian astronaut into space, Mark Garneau. And I'm going to talk about that a little later on in my talk in Randy's place. But one of the reasons Mark Garneau and all these other various people have been able to go into space is because we contributed the Canadarm to the Shuttle program. Now you're probably wondering, what is this slide about? Well, the Canadarm is actually kind of a child of these two things here. One is an early version of the Hubble Space Telescope. For a time when they were building it in the 70s, they called it the Large Space Telescope. And the reason I put this up instead of a picture of the real Hubble is because in the early days, they didn't really have digital photography, and they were trying to figure out how they were going to get the images from the space telescope down to Earth. They're still kind of hooked on photography with film and all that. And so they were thinking of having a telescope that was regularly visited by astronauts. And they were also thinking of one where they would have little arms move the film around so that it could be retrieved by the astronauts. And in the 70s, the folks at NASA Goddard, which is the NASA Space Center, which runs things like the Hubble Space Telescope, they were thinking about this problem, and a fellow named Lloyd Secord, who is an engineer from the Toronto area, came to see them, and one of the products he had was robot arms that were built for CANDU reactors. CANDU reactors are different from reactors made in the United States. When they use fuel rods with uranium and things like that to heat things up and create power, but when they want to change them out, they have to turn the reactor off, and then somebody has to go in and change them. The CANDU operates in a different manner, and they can actually change out the fuel rods while the reactor is operating, but you want to use robot arms. So Secord was from a firm called DSMA. The initials, his name was the S in DSMA. So they'd already started to build these little arms, and he said, well, maybe we could build something for your space telescope. Well, so that kind of got NASA thinking a little bit about maybe looking north of the border for a robot arm. And soon the space telescope changed, but they realized that they needed a robot arm for the shuttle to do its various things. So that's how it got going. It's an interesting story, and actually one that I finally discovered. There was a few stories going around, and they didn't make sense, and then I tripped over the right documents which tell this story. So, there also were some changes in how the government looked at space. Now, the fellow in the glasses at the left there is a guy named John Chapman, who's acknowledged to be the father of the Canadian space program. He was in charge of building that Alouette satellite up there, and then he kind of moved up in the ranks, and in 1967 or 68 he was commissioned to write a report which is widely hailed as the blueprint of Canada's space program. And as a matter of fact, the Canadian Space Center just outside of Montreal is named after him. Now, I actually disagree about some of the things that are said about him, that his report was a blueprint, because there was nothing in it at all about getting involved in human spaceflight. It was a very good blueprint for the time. They were talking about communication satellites and things like that, which is a big priority for the Canadian government. But it was silent on getting involved in human spaceflight. And of course, the reason for that was because at the time, it looked like spending a lot of money without a great deal of payback. And even though Apollo was going there, a lot of people were saying, well, do we really need to spend all that money up there? So there was nothing there. And And then in 1969, NASA came calling to Ottawa. The administrator of NASA came up and said, well, we're going to have a program after Apollo. We aren't exactly sure what it's going to be, maybe a space station or maybe a shuttle or maybe both, but we'd like you to get involved in it. And they were also asking Europe and Japan to get involved at the time. And Europe decided to get involved, but Canada didn't, because there was no policy. They just said, we aren't interested, we don't want to spend the money. And but still there was a lot of talk about it. And there were some people inside the government, a fellow named Frank Thurston, who was at the National Research Council of Canada, which of course now runs this place, and our friend Lloyd Secord at DSMA, who got together with what was then the biggest aerospace firm in Canada called Spar Aerospace. And so they began to talk about, well, why don't we build an arm for the shuttle, and it might develop into something, you know, that can create jobs and exports in Canada. And this bubbled along for a while in the early 1970s. And then in 1974, there was a woman named, in the middle here, Jeanne Sauvé, who you might recognize. She was the first woman speaker in the House of Commons and the first woman Governor General. And my one encounter with Jeanne Sauvé was when I lived in Montreal. I was driving down Sherbrooke Street at 2 in the morning and was driving in front of the Ritz. And all of a sudden, the Vice Regal limousine pulled in front of me, and I said, boy, she knows how to party. So, but anyway, in the early 1970s, Jeanne Sauvé was the Minister of State for Science and Technology, and she brought out the first space policy for Canada, formal space policy, and it included money to build the Canadarm. So, so under her watch, the NRC and NASA began to work on the Canadarm. Now you're wondering, what about the space agency? Well, we didn't have our Canadian Space Agency for another 15 years till 1989, so NRC ran that. Now, one of the consequences of that decision was that by the time we got going with the Canadarm, the Americans had signed a deal with the Europeans to build a lab to go in the space shuttle, and then NASA invited Europe to send astronauts into space. And so soon after the Canadarm started flying, Canada got a formal invitation to send astronauts into space. So what you see there is the original 6 astronauts who were chosen in 1983 to fly into space. And that wouldn't have happened if we didn't have the Canadarm and didn't have a policy to get involved in the shuttle. So the Canadarm's first flight was on the second flight of the space shuttle with Joe Engle and Dick Truly. And when we came in, Bob was telling me about his adventures going to the Cape to see that launch. So it was the first time a spacecraft had been launched for a second time with humans in it, and they ran the first test of the Canadarm. Now the deal we had with NASA was that Canada did the research and development and paid for it for the Canadarm and gave the first arm to NASA. And NASA subsequently purchased 3 other arms, and actually they purchased a 4th because one of the arms was lost in the Challenger disaster. And so shortly after, a couple of years after STS-2, we had the flight of the first Canadian into space. Now this slide I just added to this presentation about 2 hours ago. These photographs were taken by our friend Randy Attwood, and I happen to know where to access them. So, so this is Randy's little contribution, and I'm sure he would have been showing these photos and talking about how he took them. But of course, this is in front of the, or sort of in one of the alcoves, I guess, of the famous Operations and Checkout building, which has been used since Apollo. That's where astronauts stay before their flights, and then they come out to get into the Astrovan to go out to the pad. So this is in his first shot, Randy kind of missed Mark Garneau, but then in a second shot, he got Mark quite good. So this was an interesting flight because the crew, you can see the second from right is Sally Ride, who is making her second flight, and in front of Sally Ride is Kathy Sullivan. So this is the first time we had 2 women go into space at the same time, and Kathy Sullivan was the first American woman to walk in space. And she might have been the first woman, period, to walk in space, but of course the Russians got wind of her mission and sent up Svetlana Savitskaya to beat her to the punch. And then this is the commander, Bob Crippen, and you can see Mark there. So they had a very busy mission. And these are a couple of other pictures that Randy took. This is the shuttle. In this case, it was the Challenger. It was on the Challenger flew, what, 11 or 12 times before it had its accident. So this is one of the flights. And I was down there for another flight and saw a similar view, these spectacular sunsets and the redness and the shuttle all lit up on the pad. And then the next morning, quite early in the morning, I believe, it blasted off, and Mark Garneau became the first Canadian into space. And he has subsequently, he flew 2 more times after that, and then had a career in politics. And he is going to be putting out his memoirs later this year. So keep an eye out for that. I think he might even be appearing. Bob was telling me he's appearing at Bolin Books, and Bob is going to be moderating the event. They haven't set the date yet, but anyway, I know that book is coming. So the Canadarm was used for many purposes, but most famously for the Hubble Space Telescope. But in the case of Hubble, there was one deployment mission, which we see here. This is the moment the Canadarm released the shuttle, or the space telescope, after lifting it up out of the payload bay and then releasing it. And 5 missions returned to Hubble to do repair work on the Hubble. And we all remember or maybe not all of us anymore, but when the Hubble was originally deployed, the mirror was precisely ground to the wrong shape, and they had to figure out how to fix it. And what they did was basically, in effect, take the instruments that are inside Hubble and fit them with contact lenses. And they changed them out. And so for a couple of years, Hubble was a byword for failure. You know, if you ever see Naked Gun 2.5, you see all these. There's this scene where there's this restaurant and the decor is all these failures like the Hindenburg and the Edsel and various other things like that. And there's Hubble. And but after they fixed it on the first repair mission, it's become a byword for success, and it's been in orbit now for how much? 34 years, something like that, and it's still going. But the picture at the right shows how the Canadarm, one of the many uses of the Canadarm. First of all, it grabbed Hubble and put it into a cradle, and then it was used to move the astronauts around. The Canadarm does a lot of work that might and actually reduces the time that astronauts have to spend spacewalking for things like the Hubble and building the space station. And if you read Bob's book, you'll find out what really hard work spacewalking is. So having something like the Canadarm is really helpful. So the Canadarm, the shuttle has flown 135 times before that project ended, and you know it's what 13 or 14 years ago that the shuttle program ended. It's amazing how long that was, but it flew for 30 years, 135 times. 90 of those flights it had the Canadarm on board, and the second disaster involving the shuttle was the Columbia disaster in 2003, and NASA decided that the shuttle would only fly, the remaining shuttles would only fly if they were able to do really thorough inspections of the heat shield on the underside. So they actually built an extension to the Canadarm called the orbital boom sensor system. I think that's what they call it. And so you can see it here. This, of course, was also built in Canada. You can see the Canada word mark on it, and that was used to ensure that the heat shield on the shuttle was in good shape. Now, what's this other slide? This is actually something that never happened, but for a time, NASA, to make sure the astronauts on the shuttle flew in safety, they were going to cancel the final servicing mission for Hubble. And if that had happened, you know, Hubble would have died years ago. And so for a time, there was quite a protest from astronomers and others at the time. So NASA gave serious consideration to actually build a spacecraft that would dock with Hubble, a robotic spacecraft, and it would use, in effect, the Canadarm2 and the Dexter robot hand that was being built for the space station. They gave serious consideration to that, but they never did it. And that's sort of an interesting what if in the story of the Canadarm. But you know, one of its the enduring parts of its story, of course, involved the space station, which first started coming together in 1998, and the original Canadarm on the shuttle was an important part of that story doing construction, but Canada contributed what they call the mobile servicing system to the space station, and that has three parts. One of them is Canadarm 2, which is kind of a more versatile version of the original Canadarm, and the robot hand called Dexter, which is quite an amazing device on its own. And then it has kind of a little rail car that goes up and down the part of the space station. And it was shown in one of Bob's slides when we were trying to figure out where that spacewalker was. But they have part of our contribution to the station moves along that portion of the station. And so the big moment for the Canadarm was as Bob mentioned, was on STS-100. Chris Hadfield was on the crew and was involved in installing Canadarm 2 on the station. And the other parts of the MSS were installed at other times. But you can see in the slide at the right there the handshake between the original Canadarm and Canadarm 2, and that was in 2001. And just to kind of wrap up, this is a shot of the space station, and you can see the Canadarm up here. It's not very big, but it's still an important part of the station. And then the other shot shows Canadarm 2 and Dexter, and you can see a Dragon spacecraft there. It's still a very important part of the station, and in fact, the contribution that Canada makes by building and maintaining the mobile servicing system translates into our share of astronaut time on the station. And an earlier slide, I showed you the logos of the NRC and Spar Aerospace. Well, of course, that's changed today. Spar got out of the space business, and it's now MDA Space, which is the main contractor for Canadarm 2, Canadarm 3, and in the later days, the original Canadarm. And MDA Space has its origins in a firm that started up in Richmond, BC, back in the 70s, building satellite stations. And then, of course, the NRC is still involved in space in facilities such as the one we're standing in, but things like the station and the Canadarm and the astronaut program are part of the Canadian Space Agency. So I will leave it there, and this is an important part of our great history in space exploration. Thank you.
Anybody have any questions?
MDA was a structural contractor on the Hawaii telescope years ago.
They started in Richmond, actually.
Oh, I see. Maybe it's another company.
Yeah, it was originally McDonald, Detweiler and Associates. And the story of MDA is very complicated because the ownership changed a few times, and at one point the company was turned inside out. It would just blow your mind, all the changes over the years. But that's what it is today, and I believe it's Canadian owned right now. So
Funny thing about the difference between Canadarm 1 and 2, the first Canadarm in the space shuttle acted like your arm. That the shoulder was attached to the shuttle, then it had an elbow and a wrist and a hand, so it could pick things up and do this. Canadarm 2 has two hands, one on either end. So one holds onto the station and the other does whatever they want to do, or they can have this one hold on and have this one do things. And it can, if they want to, it can actually walk.
That's right.
It can walk itself around the station like this, like a big inchworm. And I was at the handover when MDA gave it to NASA. I was there, and they had it all spread out. And I asked one of the engineers, I said, "What happens if both hands let go?" He said, "Won't happen. Won't happen." Never happened. But I thought it was pretty funny. They're also very strong. The Canadarm 2 was designed to be able to dock the space shuttle, because they weren't sure that the astronauts would be able to bring them in without hitting something. So the Canadarm was built strong enough that it could actually reach out, hold onto a space shuttle, which weighs 90 tons, and pull it in for docking. So it's strong, but they never did that. The astronauts managed to do it themselves. Oh, question, yeah.
I noticed.
Oh. So I didn't mean to steal your thunder.
I noticed
No.
in. Hello? Okay. I noticed when you were describing that recent spacewalk, private one, that you were poking fun at. The coverage of that said they were testing some really innovative suits.
Yeah, they were.
Can you say more about that?
Yeah, the SpaceX has designed a new spacesuit that could be the future. As you can see, it's more skin tight and it's more mobile, and that's really what he was doing. They were testing the joints to see, because there's a joint on the elbow and there's a joint and wrists. Those all have to be mobilized, and they have to make sure when they're out in a vacuum that they don't leak, that they can move but they're still airtight. So that's really what he was doing, was just testing the mobility of it. So yeah, SpaceX, as usual, they're doing things much cheaper than NASA is. They're taking people to space while NASA's Starliner had to come home alone. So keep your eye on SpaceX. They're going to do a lot, and I believe, including going to the moon. So yeah.
I heard recently that they were going to disassemble the space station and basically burn it up in re-entry, and hopefully none of the parts hit anything important. Is that true, or is that just
Yes.
fake news?
Yeah, well, the agreement covering the space station goes until 2030, although I wouldn't be surprised if it goes a little further than that. But they're already developing plans to re-enter the space station into the atmosphere, and this will be similar to what they did with the Mir station, that it will go into kind of a zone in the southern Pacific where there isn't much ship traffic, and whatever there is will be warned away, so that it will just splash down harmlessly. It's just very expensive to maintain, and there are plans for future space stations, although they'll probably be built privately. NASA is encouraging that. So in the early 2030s, it may come back. And also, that's roughly the same time that Hubble may come back too. But they're talking about building a robotic spacecraft that will go there after the astronauts leave, and then it would fire its engines to slow it down so that it ends up in the right spot.
Yeah. It's interesting how they do that. They because it's on a circular orbit around the Earth, 400 kilometers up. It's angled to the equator, what, 50 degrees, I think?
Yeah.
So it's going around this way. But they'll put up probably a Dragon capsule, which has thrusters on it. So they'll attach that to the space station, and they'll push it and actually accelerate it up to a higher orbit. So it'll be an elliptical orbit that'll go high and then low and high and low, and the low point will be at sea level, so that it'll come down here in the southern Pacific, which is the largest body of water with nobody in it. So that's where it'll come down. Be one heck of a sight. Can you imagine seeing that come through the sky? Woo!
pair astronauts on the Hubble, they came from the spacecraft, the what do you call that? The International Space Station?
No, because Hubble and the space station are in very different orbits. So they had to have dedicated missions with the shuttle. So the shuttle would come up to Hubble, the Canadarm would grab it, and they sort of had a little cradle they could park it in, and then the Canadarm was free to move astronauts and also instruments around.
So the shuttle was very close to the Hubble.
That's right. Yeah, well, they were
Attached to each other.
they were attached to each other. Yes. Yeah.
The Hubble's higher than the space station.
Yeah.
So it's hard to go, you can't go from one orbit to another very easily. It takes a lot of energy. So.
Yeah, there was that scene in Gravity where they go from one to the other, but that can't
It's
happen.
not like that. Yeah, it's not like that.
Is there anybody else? Is there anyone else that has a question?
Great.
I've got one last one I would like to ask, and just maybe more than just a yes or no. Do you think that people should be continuing to put people up in space, or should it become robotic? Bob?
Both. I'm a big fan of the robots. I followed the robots. I made regular pilgrimages to the Jet Propulsion Laboratory in California where they control the robots. I was there for Viking in 1976, for Voyager, all of its missions to Jupiter, Saturn, Uranus, and Neptune. I even went to the Pluto mission in 2015 in Baltimore, Maryland, where they control that. The robots are the true explorers. They go boldly where no one has gone before, and where no one will go in some cases, like to Jupiter or Saturn. So they're doing the primary surveys, the exploration, but when it comes to capturing the public imagination, it's the people that capture the public. You know, nobody celebrated when, what was it, Surveyor 1 landed on the moon?
Right.
Nobody celebrated that. Nobody can even remember the first robotic landing on the moon, but the first step on the moon, whoa, we're all in there. So the human part takes up most of the money, which is too bad. And they don't do exploration, really. So we need both. We need both. We need the robots to go first, map out the area so we know what's there, and then the humans can go. Whether we'll continue to support the human space program, that's probably going to be SpaceX that will do that. Because Elon Musk is building his big Starship, and he wants to fly that to Mars, and it'll be capable of doing that. But it's not going to be a migration like it was from Europe to North America. It'll be a few people. It'll be like living on the South Pole, because Mars is a really interesting place. Good skiing at the North Pole. I'd love to do that. Low Martian gravity, it's only a third what it is here.
Olympus Mons.
But yes, and Olympus Mons, the tallest mountain in the solar system. But it's cold, it's dry, there's no oxygen, there's no ozone layer to protect you. You got to wear a spacesuit all the time when you're outside. It's a harsh, harsh, harsh place to live. And if something goes wrong, you can't call the ambulance. It's 7 months away just to get there. And if you want to call home, there's up to a 20-minute delay just to say, hi, how you doing? Not bad. That took 40 minutes to do that. So yeah, there will be people on Mars, but I don't think we'll become a two-planet species like Elon Musk says. But we will go there with people. But I hope they keep the robots going. They don't sacrifice the robot. A long answer, but I think we need both.
Well, in a certain sense, there's no real alternative to the robots. I mean, once you get beyond Mars, pretty well everything you want to go is you know, even scores or hundreds of times more hostile than Mars is. You know, you go beyond Mars, there's the gas giants. You know, we can't really go there, or the radiation environment at Jupiter. It's just really a tall order, and you know, unless somebody finds out a way to violate the laws of physics, you know, it's not going to be possible to kind of have a Star Trek type thing where you just whiz around from one.
Bring on warp drive. Bring on warp drive. We really need warp drive.
That's right.
Maybe you'll be the one to invent it. Okay, work on that. Okay. Work on inventing warp drive. We really need it. We really need it.
So I can see humans going to Mars, but when you get beyond that, it's pretty well robots.
Mm-hmm. Yeah, and even they take centuries to go anywhere. Yeah,
That's right.
yeah. Okay.
Thank you, Bob. Thank you, Chris, for taking on the role of three people. We really appreciate that, and we'd like you to. If you want to, you can kind of stay around a little bit. I think we might see if we could put out a couple of telescopes and see if we could get something on the deck. We'll see whether we can get that going. And we're very, very happy that you came up. Thank you so much for supporting us, for supporting the Friends of the DAO and the RASC, who invited everybody to come up here tonight. So thanks a lot, everybody.
Thank you. Thank you very much.